Today we're looking at isosceles and equilateral triangles, and specifically we're going to look at the isosceles triangle theorem. Now, the isosceles triangle theorem, dealing with isosceles triangles, remember isosceles triangles are triangles that have two congruent sides. If they're isosceles, they have two congruent sides. Remember, if they're equilateral, meaning all sides are congruent, it's an equilateral triangle, and if they're all different sides, lengths, then it's scalene. So we've got isosceles, equilateral, and scalene. We're looking at specifically these two kinds today, and we're going to look at the isosceles triangle theorem. It says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So looking at this picture of an isosceles triangle, triangle ABC, we have two congruent sides. That means the angles opposite these two sides, which would be angles 1 and 2, are congruent to each other. So 1 is congruent to angle 2. Now the other thing is, the converse of that theorem says that, well, if we have a triangle that has two angles congruent, then the sides opposite are also congruent. So it would be the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. All right, so let's look at this diagram and try and find two unmarked congruent angles. Now we have two that are marked. It says that this angle and this angle are congruent. Those are marked. Let me actually use a different color. Okay, this angle and this angle are congruent. Now unmarked, we have basically two triangles. One of the triangles has two angles that are congruent. One of the triangles has two sides. Notice this triangle. It has two congruent sides, which means these angles are congruent based on the isosceles triangle theorem. So those would be angles BCA and angle BAC. So those are two unmarked congruent angles, which we can figure out because it's an isosceles triangle. Now the second one says to name two unmarked congruent segments. Well, if we're looking at this triangle now, we have two sides congruent, or two angles congruent, and using the converse of the isosceles triangle theorem, we can say that, well, if the angles are congruent, then the sides opposite those angles are also congruent. So those segments would be CB and BD. Those two segments are congruent. Okay, now we're going to look at an equilateral triangle, and this equilateral triangle corollary says that if a triangle is equilateral, meaning all the sides are congruent. I'm sorry, it's not an if-then statement, but it's just a corollary, not a conditional statement. So a triangle is equilateral if it is equiangular. That means that all of these angles are congruent. So if we have a triangle and all the angles are congruent, well, that means that it's equiangular, therefore it's also equilateral. All the sides are congruent. And if we have a triangle with all the sides congruent, all the angles are congruent, then each angle measures 60 degrees. Because remember, the sum is 180. They're all equal to each other. 180 divided by 3 equals 60. So let's look at this diagram. We have a triangle with two sides that are congruent. Notice this side and this side are both 5, so they're congruent. So if those sides are congruent, that means that these angles are congruent. It asks us to find the measure of angle R, this angle right here. We don't know the measure. I do know that the sum has to be 180, and one angle is already 40 degrees. So if I take 180, subtract 40 from that, I get 140. So between these two angles, they have to add up to 140, and they're equal to each other. So we just divide that by 2, which 140 divided by 2 is 70. That means that angle R is 70 degrees. Okay, and looking at the same picture, we need to find the length of PR. Well, again, these sides are congruent, meaning these angles are congruent. But in this one, there actually is not enough information to find out what the length of PR is. Nothing about it says that they're congruent. If we had had all three angles being congruent, then also the sides would have been congruent. We would have said 5, but since they were not all congruent, there's no way to find out what the measure or the length of segment PR is. All right, and the last page on this note says to find each variable. So what we have is an isosceles triangle, or at least I know that these two lengths are congruent, which means this length, 8y minus 5, is equal to 6y plus 3. So I can find y by setting those equal to each other. Subtract 6y. Add 5 to both sides. Divide by 2 and y equals 4. So that's one variable. Well, if they're isosceles, or if these two sides are congruent, that means these two angles are congruent. And if angle E is 4x minus 8, then angle D is also 4x minus 8. But if you notice, this angle is 4x minus 8, this angle is 4x minus 8, and this angle is 4x minus 8. That means all the angles are congruent. They're equiangular, the triangle is, which remember, each angle of an equilateral or equiangular triangle is 60 degrees. That means, in this picture, 4x minus 8 equals 60 degrees. And then we just solve for x. Add 8 to both sides, divide by 4, and x equals 17. Okay, we're not going to look at this proof, so let's look ahead straight at the assignment. Okay, in this problem, we're going to classify it based on its angle. Remember, if all the angles are less than 90 degrees, then it's acute. If you have one angle that measures obtuse, that's an obtuse angle, then it's an obtuse triangle. If one angle is a right triangle, it's a right triangle. And if all the angles are equal, it's equiangular. Then based on the sides, 2 congruent sides, isosceles, 0 congruent sides, scalene, all congruent sides, equilateral. So you'll have 2 names for each triangle. Number 4 is a little tricky because they give you 3 points, the vertices of the triangle, and you're going to find the measure of each side, and then classify it, whether it's isosceles, scalene, or equilateral. Now, in order to do that, you need to find the length of each side. XY, YZ, and XZ. Well, in order to find the length of these, we need to use the distance formula. If you'll recall, all the distance formula really is, we subtract the x's, square it, and add it to the difference of the y's squared. So for xy, we're going to be using these 2 points, and we're going to say 7 minus 5 squared plus 6 minus 1 squared. Well, 7 minus 5 is 2, so that's 2 squared. Plus 6 minus 1 is 5 squared. We end up with 4 plus 25. So xy is the square root of 4 plus 25, which is 29. That's xy. I've got to do the same thing for yz, same thing for xz. If they're all three different, it's scalene. If 2 are the same, it's isosceles. And if all 3 are the same, then it's equilateral. Okay, I think those are the most difficult questions that you'll get. If you can't read the second page, we have a problem number 12. That angle right there is 46. Okay? All right, good luck on the homework.